Hi, my name is Emma Vierheller. This is my application for the Desmos Fellowship. I want to take 2 minutes and explain how I'm integrating Desmos into a lesson to show my students and have them prove how all circles are similar to each other. So what I have in front of you is a quick activity. This would be a warm-up activity. My students would walk in, and this is what they're going to walk through, is we're going to talk about what does it mean for two figures to be similar. They've heard of the word similarity. They mix it up with congruence quite a bit, so I want to look at their sketches and see what they come up with. Then we're just going to do a little compare and contrast about these circles. What's similar? What's different about them? Or what's the same? What's different? Are they similar? Then they're going to see if they can answer the questions, are circles dilations of each other? They've also worked with dilations. They know about centers of dilations and scale factors. We've covered that before. I'm a little curious to see what they still know. They're going to find the center of dilation. They're going to find a scale factor. They're going to translate these circles. And at the end, I want them to answer the questions, do they think that all circles are similar to each other? And I'm really curious to see what they come up with. So there's the activity that I would use at the beginning. After we've had some time to talk about whether or not we think all circles are similar, then I have this graph to bring up. All my students have mini whiteboards at their desks. And I'm going to bring up this graph that has two circles. I can move the centers of both of those circles, and then I can also change the radii of both of those circles. So what I would be working with my students is I would show them two circles, and I would ask them, how does the green circle need to be changed in order to be congruent to the purple circle? And so what we do is we talk about how we would translate the center and then dilate that green circle that it lands perfectly on the purple circle. And we're going to go through a couple rounds of that. Luckily for my purposes down here, I have scale factors and I have the translation, so I can check that pretty quickly. And this gets really fun because my students can quickly and easily shout out, oh, I want the center to be here. I want the center to be here. And we can move through that pretty quickly. We'll try it a couple times. Remember that I'm trying to get more to the point that all circles are similar to each other, but going through a few rounds of, okay, how does this circle need to move? How can circles move? And getting them comfortable with that is going to make the proof that we're going to do a lot easier. So after we walked through that activity, my students and I would actually go through the proof of showing that every circle can be a dilation of another circle. So instead of using actual coordinates like I have over here, we'd have a general formula for the general equation for a circle. We'd talk about how that would be translated and then what the scale factor in general would need to be based on a radius of any length. And we're trying to get to that proof. What I really like about Desmos is that these things are integrated really seamlessly into my lesson. My lesson is not the tech. The text supplements the discussion that's going on in my lesson. So for example, when we're talking about whether or not we think all circles are similar to each other, and we're going through some of these things, my classroom's often a lot louder than it is, which is kind of the opposite of what often happens when we put a Chromebook in front of a student, is we do it to give them something to do to make them be quiet. I like that my classroom gets louder when we're working through a Desmos activity together. I like that the energy level is higher, and that when they see that we're going to do a lesson on computers, to them it doesn't mean that we're doing practice problems on a website. No offense to the companies that go for that, but that's not what I want to do when I'm using tech in my classroom. With this graph, I love that it's so easy to move. This didn't take me long to set up. My students can understand, and I've had my students set up something similar on their own before as well. So they feel like this is really a confidence builder for them that they're able to build something like this. And because it's so easily movable, it keeps our class really dynamic. So here are two quick tools that didn't take me that long to put together, and they're really elevating the level of discussion and energy in my classroom. And that's what's really exciting to me and why I like to use Desmos a lot in my classroom. So hopefully that gives you an idea into what I'm using Desmos for. It supplements my application, and if you have any questions, feel free to contact me. I'm in rural Northwest Ohio right now where it's freezing rain, so the idea of coming to California right now sounds absolutely lovely. But more than that, I really get excited about collaborating with other math educators, and I can't wait for the opportunity to learn more from other people. Thank you.